let's find the slope that has the points a, -3, 5, and b, 2, -7. So we can start off by remembering what is this formula for the slope of a line. So the slope of a line, m, is going to equal the difference of y sub 2 and y sub 1 and x sub 2 and x sub 1. So basically we're just looking at the change in the rise or the change in the vertical movement over the change in the run or the change in the horizontal movement. So let's go ahead and label our points. So we have A, we have x sub 1 and y sub 1, and B, we have x sub 2 and y sub 2. Now we can go ahead and fill out our equation. M equals y sub 2, which is -7, minus 5, over 2 minus -3. -7 minus 5 is -12. 2 minus -3, you need to remember that 2 minus -3 is the same thing as 2 plus 3. Okay, so then I would have -12 over 5. So the slope of my line would be -12 over 5. Number 4, given the set of ordered pairs below, answer the 3 questions. What is the domain? So we remember that the domain are the values of x, or the input values. So my domain would be 4, 5, 2, 4, 6, and 7. Now we remember that our range are the y values, or the outputs, or the dependent variables. You can call it so many things. So my range would be 2, 1, 2, 3, 4, 5. Is this function a relation? Is this a function or a relation? Well, let's look at this. In this example with these ordered pairs, we have 2 values of x. We have 4 with a y value of 2, and we have 4 with a y value of 3. So this cannot be a function. It has to be a relation, because x, when x equals 4, it has 2 different outputs in the range, 2 and 3. So it cannot be a function. So what we're going to do in this problem is we're going to complete a function table using independent variables that are given. Remember, independent variables can also be referred to as being the x values. So we're going to use -2, -1, 0, 1, and 2, and we're going to put those into the function table under the x column. We can go ahead and write those in. So we're going to have x values that begin at -2, -1, 0, 1, and 2. And then we can just write our function in here of 1/2 x minus 2. So when we evaluate 1/2 x times -2, we get -1 minus 2. So my y value would be -3. 1/2 times -1 minus 2 is -1/2 minus 2, which would be -2.5. 1/2 times 0 is 0, minus 2 is just 2. 1/2 times 1 minus 2 is going to equal -1 and 1/2. And 1/2 times 2 minus 2 is going to equal 1 minus 2, or -1. And note that when I evaluated x equals 0, I got 1/2 times 0 minus 2, and we should have gotten a -2 for the answer. Okay, so what I'm going to do is graph -2, -3, negative 1, negative 2.5, 0, negative 2, 1, negative 1 and 1/2, and 2, negative 1 on a graph. That would look something like this. Okay, so I can go ahead and graph my first point of negative 2, negative 3. So I go negative 2, negative 3. So it'd be somewhere around there. My second point, negative 1, negative 2.5, would be somewhere around here. 0, negative 2 is going to be right here. 0, negative 2 is the y-intercept. 1, negative 1 and 1/2, and 2, negative 1. If I draw a line through that, I'm going to have a function that looks like this. Okay, so this makes sense because 1/2 x is positive, so I know that I'm going to have a line that has a positive slope. I know I'm going to have a line that has a y-intercept of negative 2. So we can see that this line hits the y-axis. Okay, this is the y-axis and the x-axis. I have a line that intersects the y-axis at negative 2. Let's write the function table using the same independent variables of x as negative 2, negative 1, 0, 1, and 2, and then graph the result on the coordinate plane. We need to look at the function that we were given and realize it's not in slope-intercept form. So we need to rewrite this so that we have y by itself on the left-hand side and everything else on the right-hand side. So what we'll start off with doing is just by subtracting 9 from both sides, which would give us 3y equals 12x minus 9. The next thing we would do is divide everything by 3 to get rid of the 3 next to the y. So that's going to leave us with y equals 4x minus 3. So we have a positive slope because our coefficient of x is 4. So we know we're going to have a line that's sloping up to the right side or going up through quadrant 1. Let's go ahead and fill in our values of x. We have negative 2, negative 1, 0, 1, and 2. Our function is 4x minus 3, and we want to go ahead and solve for y. So 4 times negative 2 minus 3 is negative 8 minus 3, which would be negative 11. 4 times negative 1 minus 3 would be negative 4 minus 3, or negative 7. 4 times 0 minus 3 is just negative 3. 4 times 1 minus 3 is 1. And then finally, when x equals 2, 8 minus 3 is 5. So we have coordinates of negative 2, negative 11, negative 1, negative 7, 0, negative 3, 1, 1, and 2, 5. So what we can see is what's going on is that each value of y is going up by positive 4. Okay? So each value of y is going up by positive 4. Each x value is going up by 1. Okay? So what we're looking to do is do our graph. So I'm going to do a really quick graph. So it looks like I need negative 2, negative 1, 0, 1, and 2. And then I need on my y, I'm going to need to go up to positive 5 and down to 11. So let's see if we can do that. 1, 2, 3, 4, 5. 11. Okay, that's not the prettiest graph, but I think we'll figure it out. So my first is -2, -11, so that's going to be down here. -1, -7, so right here. 0, -3, that's the y-intercept. 1 and 1, up in quadrant 1, and 2 and 5. So what we have is a line that looks like this. Again, this is a fairly steep line because our slope is 4. So remember, when you're looking at slopes, the larger slopes have more steep lines. The smaller the slope, the flatter the line.